side is already new, while the other half is still old, and then you get a lot of errors. Well, SVN can really help by doing that on the server. It just updates everything in one go. It's also important to look at the database because code is just one part of the application, but you also have data that you need to migrate. So it's always useful to do things with, for example, patch files. A lot of development teams, just manually patch the database. They upload the application and then they go into their MySQL or Oracle database and they say alter table, add a column here, or update table, put some data there. That's really, you can really get a lot of errors if you do that manually because, the guy that always does it is sick and somebody else has to do it now, but he just doesn't know all the changes that were made, so he misses a table. What we really like to do is, use patch files. Whenever we make a change into the database, we just write a little SQL script in which we put the alter table statements, and then all we have to do is, run the SVN update and then see what new patch files there are, and then patch the database. Makes it also easier for your development environments if all developers no longer have to manually tweak a lot of databases, but just can run a little patch file that will update your database. For large projects, it's always useful to create what is called a deployment and release profile, and that's basically a little document that describes, how an update is done. It basically describes you run your tests here, then you run an SVN update there, and these are the steps you need to take. This is the customer that you need to call. If you document that, that makes it a lot easier that if your main developer gets hit by a bus, that somebody else can take over because you've documented the process and you don't have to worry about how things are done. It also gives confidence to the customer. If your customer can see, hey, this is the way updates are rolled out, he can really see, we're not just fiddling around, we have an actual process of deploying a new version of the application, and that gives a lot of confidence to a customer. Another thing to look at when doing deployment is to look at, the system architecture. What are we deploying on? Deployment can range from anything from a simple stack where we have one machine that runs, MySQL and PHP and Apache and Linux and everything on one machine. But on the other end of the spectrum, we might have high available scalable architectures. And it's really useful to look at, what does the customer need? For example, if you have requirements like an application may never go down, you need to have some redundancy in there. And if your application needs to be scalable, if you expect that your visitors are going to grow by 200% a month, then you need to have a scalable architecture. And this is an example of such an architecture where we basically see that, I'm not sure if you can, I don't have a cursor. What you basically see is that, you have a set of web boxes that are basically your front-end servers. You have a set of database servers. You have some load balancers in between that are all redundant so that if one machine breaks down, the other one can take over. And you have, for example, your storage solution. This can be anything from advanced storage equipment to something simple like NFS file servers. But the interesting thing in an architecture like this is that it's what's called horizontally scalable. If you need more database processing power, you can just add a machine here. If you need more web power, you can just add a machine there. If you need more storage, you can just change the infrastructure there. That's a lot easier if you have an architecture like this than when you're running everything on a single box and you have to duplicate everything to multiple boxes. This is a lot more scalable. So when you deploy a serious application, it's really worth spending some time on the architecture of the application, on the architecture of the system that the application is going to run on. The last step that I'm going to discuss is operations. Once your application is live, the project doesn't end. Actually, just for the customer, it just starts. And it's really important to also look at this part of the process. For example, simple things like monitoring an application, things like log files. And there are a lot of things that you have to take care of. What I've seen in the past is, development team writes a big project, adds a lot of logging because then they can see what happens. They put an application live, and then within 20 days, the application goes down. What's the problem? Disk space is running out because we're logging so much, we're just putting that into files and nobody's ever looking at it. So if you do things like logging, you really have to take care of cleaning your log files, actually looking at them, rotating them so that, for example, log files older than 10 days are deleted. Because if you just put everything in a file, then eventually you are going to run into disk space problems. Instead of just logging the application, it's also important to monitor the infrastructure. There are tools such as Nagios that can basically tell you, hey, there's a hard disk failure on this machine, or the load is going up on that machine, so you can really see the impact on your hardware. For PHP, there are tools such as Zen Platform. There are probably similar for other languages to monitor the application. Not just the things that you are writing in a log file, but also is the application still working? Are we getting parse errors? Is a file missing? Are we running out of memory? All kinds of application-related failures. And it's important to monitor those as well. And the final one that's often forgotten is to monitor the business. If you write a large enterprise application that, for example, deals with transactions, with e-commerce or something, then it's really useful to monitor that so that you can see, hey, we're doing like 10 orders an hour, and now we've dropped to 1. What's wrong? Even if all the software is working and we don't have any errors in a log, something is still wrong. Maybe a user just put something in a database that's not correct. Maybe they just deleted, all their products from the database. By just monitoring simple things like, how many transactions are we doing? Is the business still running? That really makes it easy to monitor and see if things are going wrong. Another thing that you have to take care of, in operations is debugging a problem. And what happens a lot, what you would like a user to say is, hey, when I clicked here and I did this, then I got an error, and these are the details. But that's not reality. In reality, users are always stressed, and something like the below happens. It doesn't work, and they don't tell you what doesn't work. You just have to fix it because it doesn't work. Panic is imminent. What's important here is, to educate the users, to basically tell the customer what you need to know to be able to fix the problem. Just it doesn't work will not get you the details that you need to fix his problem. So if you educate the user and tell him, whenever you encounter a problem, please write down these and these items. What were you doing? What button did you click? What screen were you on? If you educate your user, they can help you, find the bugs more easily. What's also useful if you use what's called root and cause analysis tools. And this is an example for a product in PHP, Zen platform, that basically tells you, this is the problem that occurred, and this was the situation, this was the context of that problem. For example, a parse error occurred, and this is what the problem was. There were this many users on the database, and this was what the user posted in his form, this was what the user was doing beforehand. It basically helps you identify the problem. So even if your customer calls up and says, hey, it doesn't work, you can just go to a tool and see what the user was doing when that problem occurred. That's called context capture, and that's sometimes really useful. And it's really easy to make because, for example, if you don't have a product for your language, just make sure that whenever you log a failure, also log the context, log the variables that your script was reading, log the session that your script was dealing with, log the cookies that the user was dealing with, so that you have like a context for a problem, so that you can go to your developer, that you can go to someone and say, hey, it's not just a parse error, but there is a whole context to this problem, because if you do this and this and this, then you get a parse error, and that makes it a lot easier to fix those problems. Well, if you have a bug fix and you need to, to do change management, people request changes to your application. It's always useful to use something like a ticket system. A lot of development teams don't use a ticket system. You just go up to the developer and tell them your problem. But in large applications, chances are that you're going to have a lot of problems that you need to track, and if you just keep them in your head, you might forget them and you might not realize the priority. So it's really useful to always use a ticket system to add your changes to. It's also important, to stick to your deployment and your deployment and release profile. If you made documentation, on how to roll, how to update the environment, and just use that whenever you have to make a change. Just don't go about and hack something on the live server. You just make a change, do the tests, put it in SVN, put it on your staging server, put it on live. Use the same process all the time. And a lot of people say, hey, I need to do this on live because we have a P1 emergency problem and I need to fix this now. Chances are that if you go into the live server and you hack something, that you make a mistake because you're under stress. Adrenaline is rushing through your head and you make a mistake and you make it worse. So even if you have a really bad problem, always have this staging environment next to it where you can just fix the problem securely without making it worse. And once you're sure that you have the right change, then you can just easily commit it and update the live environment. That just takes like 5 seconds. So that's not really a reason to not do it on the live environment. Just always use a staging environment. Now, if you look at the big picture, the most important thing to take away here is that, with all these steps that we've looked at, is that you shouldn't do any cowboy coding. Cowboy coding, that's like, hey, I need a feature, I need an application. You just start writing code. The important thing is that you use structured steps, and that will help you increase the quality of applications.